Now we need to solve some examples to see what is the kinetic energy. Is it big or small or what it look like? Yes. We have example page number 6. We have some objects. We have, for example, electron. Its mass of electron is equal to something which is 9.1 multiplied by 10 to minus 31 kilogram. It is negative in the top here. That means we have 9.1 over 31 zeros in the denominator. It is very, very, very small. Okay? But its velocity around the hydrogen nucleus, the hydrogen atom, its velocity is very high. Yes, it is very light, but its velocity is very high. Its velocity for this electron is equal to 2 multiplied by 10 to 7 meters per second. If we leave this electron freely, okay, it will move 20 million meters after 1 second. It will be very fast because it is very light. Okay, what is kinetic energy for this electron? I will write the kinetic energy relation here. Look, half is just a number. And if the mass is very high, then the kinetic energy will be high. If the velocity is high, then the kinetic energy will be high. If the mass is small, then the kinetic energy is small, and so on. Okay. We have small velocity. We have high velocity. We have small mass, and high velocity. Let us compute the kinetic energy for that electron. An hydrogen atom is the first level. Okay? It is equal to half multiplied by the mass, which is 9.1 multiplied by 10 to negative 31 kilograms. Multiplied by the velocity squared, 2 multiplied by 10 to the 7 squared. This will give us its kinetic energy in joules. 18.2 multiplied by 10 to the dash negative 17 joules. Yes, its velocity is very high, but its mass is very small. Negative 31 is too much smaller, or in negative magnitude bigger than 7 to the power 2, which is 14 in this case. So the kinetic energy will be very, very small. Don't think that this fast electron, when it hits you, it will push you because of its energy. It will not move anything. But what if you have millions and millions and millions of these electrons? They will start generating electricity. By their kinetic energy. Okay, now, what if we have a train? We have a train. And its mass is equal to something big, almost, which is 600 tons or 600,000 kilograms, right? Its velocity is small. It's 25 meters per second, not 10 million. What is the kinetic energy of it? Okay. Kinetic energy for this train is equal to half multiplied by the mass, which is 600,000 kilograms, multiplied by 25 squared, which is 625. This will be equal to something equal, not small, 1875 عشان زيرو بعدين 5 zeros 1 2 3 4 5 joules. It's 187 million joules. Its speed just 25. Maybe you are faster than it when you are running or something like that. But its mass very high. Because of that, the kinetic energy for a train is bigger than electron, which is fast electron. This example will show us the dependence of the kinetic energy on the mass, on the velocity, okay? And you can compare between moving objects. Any question about this? Any question online? Okay. We have a mass. Have two velocities. Initially, V initial is equal to 10 meters per second. V final is equal to 0. I'm sorry about that. Okay. So its velocity is decreasing to reach 0. During a time, we don't have any time in our calculations now yet, because we will use it now. I'm asking now, during any time, do we have positive or negative acceleration? I'm asking. Positive or negative acceleration? Yes, you're right. We have a negative acceleration because V final minus V initial, it is negative. Okay, what else we need? We have the time, delta T is equal to 5 seconds. Yes. The mass is equal to 2 kilograms. We can find anything. The first thing, find the change in kinetic energy. Delta kinetic energy. It is equal to kinetic energy finally minus kinetic energy initially. We have the relation of the kinetic energy. It is there. I'll write it here. 1/2 mv squared. Okay. Which is equal to 1/2. The mass is 2. Kinetic energy finally, it is V final squared. V final 0 squared minus 1/2 multiplied by the mass again, which is 2, multiplied V initial squared, which is 10 squared or 100. Okay, we have 0 minus 2 will cancel with 2. We have 100. So the change in kinetic energy will be negative 100 joules. It is simple, or I'm asking, it is here. The change in kinetic energy here, it is negative 100. From this relation, the work is equal to the change in kinetic energy. What is the work? It is equal to the change in kinetic energy. Who can tell me? It is negative 100 joules. I think it is required also. The work done. Aha. Now the object is stopped after a while. What do you think this work is done? What is the force? The force acting on this object. Who can tell me? Even online. I have a moving object, then after a while it's stopped. What make object stop like this? What is the force that acting on this mass and made it stop? The force is in the opposite direction of the motion. It's the friction force. So it may be the friction force, the frictional force. The frictional force always has a negative effect on our system. Okay. What is the frictional force in this case? Okay, I have the relation, the work is equal to the force, which is a frictional force, multiplied by x, multiplied by cosine theta. I have the motion to this direction. This is the force. Again, this is x, and this is the force. What is the angle between them? What? It is 180. So theta is equal to 180. The frictional force, we don't need to know it. We need to find it. X, how much x? We need to find x, right? This one, is it? We don't know how much x. We need to find it. Okay. X cosine theta, it is 180, it is negative 1. This will be equal to the work, which is negative 100. Okay. The negative sign with the negative sign, the friction force with x multiplied are equal to 100. So 100 is equal to F multiplied by x. We can find x by using the relations of motion, equations of motion, by using this one. X is equal to x naught plus v naught t plus half a t squared. If you assume that at this point x equal to 0, x naught is equal to 0, this is x is equal to 0 plus v naught is 10, the time is 5 plus half. How much the acceleration? The acceleration is delta v over delta t. Delta v is 0 minus 10, negative 10 over 5. The acceleration is negative 2 meters per second. So the acceleration is negative 2 multiplied by time squared. The time is 5, squared is 25. This is x. It will be 50 minus 25. 2 goes to 2. It will be 25. So x is equal to 25. So 100 is equal to F multiplied by 25. ومنها F is equal to how much? Frictional force, I'm sorry. Here later. It's 4 Newton to the left side direction.